The open source Zortrax Frankendoodle lives. Well, winter has really hit in this part of the world. It's really cold outside. It's a perfect night to stay inside and do some tinkering and make my own Frankenstein's monster. In case you didn't see the first video, the aim is to take the open source RepRap electronics from this printer, which has a pretty old crusty frame, and then I want to put them into this Zortrax M200, which has a beautiful frame, but unfortunately it's had some issues that I haven't been able to fix because everything is closed source. By the end of this episode, the aim is to have the basic electronics in this. Not everything will be connected because some things are going to need wiring changes just because the pins will be different, but we should be able to get in our main board and have stepper motors and things like that moving around without too much drama. Now, the modifications performed on this Solidoodle 2 are well documented in an earlier video, but here's a recap of the electronics. It's got an Arduino Mega, it's got a Ramps 1.4 shield, and it's got some other inclusions as well that are pretty nice. It's got DRV8825 stepper motor drivers, which double the resolution, and then all the stepper motors themselves aren't the usual 1.8 degrees, they're 0.9. So overall, this should have 4 times the resolution of a normal printer, which in a nice frame should have extremely pleasing results. The other relevant thing to mention is that everything runs on this off 12 volts. I've got a really beefy power supply, and that's to handle the custom PCB heated bed that I machined. We're right on the limit of how many amps it could draw safely, and that heats up the bed extremely fast. This one, well, it's a bit of an unknown. So we might start by removing this from the table to create some space, and then flipping this one on its side and opening it up. I'm gonna remove this aftermarket window solution, which we added to try and help ABS stop peeling as much. Very easy to fit back later on if I change my mind. This side's got some bolts sticking out, so I don't want to scratch my table, therefore I'll put it the other way around. That'll also give me access to the power. Wow, that is dirty, but that's not the printer's fault. Let's disconnect this fan, and it seems obvious, but I should add that we have a power supply here with mains wiring coming in. Disconnect it before you open this up, just to avoid any possible chance of being electrocuted. Once again, the quality of this frame is outstanding. That's beautiful. Can't wait till this thing's back together and printing. Alright, here is our first potential issue. This power supply is 24 volts and our old system is 12 volts. And I know the ramps in it can only take up to 12 volts. It can't handle a 24 volt input. So we're going to have to do some creative problem solving here. One option is to just switch the power supply out from the other machine and convert this to 12 volts, but then you'll find things like the hot end and the heated bed, which aren't configured for half the voltage, will lose a lot of performance. They'll heat up a lot slower. Also need to then modify all of the fans, the LEDs, anything else that's meant to run on 24 volts isn't going to work correctly, and that's going to be a big pain in the bum. Under here we can see some beautiful cable management. Everything is in fiberglass sleeves and it's tied with these Velcro straps to the board. Everything is super neat and super tidy. Although this is a proprietary board, things look pretty familiar. We've got our stepper motor connections, we've got our power in, we've got our heated bed wiring out, we've got a ribbon cable that goes to the hot end and the extruder. One of the bigger jobs that's coming up is to make an adapter for that so I can plug in everything to the new electronics. We've got a connection for LEDs, we've got our end stops, we have something labeled sensor, and we have a single ribbon cable for the LCD. Now the LCD is something I probably won't expect to be able to change. That's unfortunate because I'd like to keep this thing looking as nice as possible. Hopefully there'll be a solution that presents itself that keeps this thing looking nice but has all the functionality of an LCD screen. I'm going to take a photo of this just in case I can't remember what one of the plugs is in future. It'll serve as a handy guide to trace back and know what is what. Other thing I'm going to do is as I pull things out, I'm going to mark them with a Sharpie on the white plug. That'll make life so much easier in the long run. That's everything unplugged. Let's remove this board. The brain is out. One other thing I'm going to do right at the start is to get rid of this perforated build platform and see what's underneath. Hopefully it's nice and flat and I can just put on build tack or another type of build surface, and that'll do in the meantime. Long term, I'll probably upgrade it to a flex plate or an Anycubic Ultra Base or something similar. Okay, now that that's out, I can show you what should have been a really nice design feature, and that's the fact that the bed is completely magnetic and removable. If it wasn't for that little connector at the back, it would have been really quick to undo the big beefy plug that supplies the bed power, and then you could pull this out and then clip it in and out as often as you needed to. It's a very nice thick piece of metal. It's got the heated PCB underneath, and I think once it's cleaned, it will be nice and flat, and it will be a beautiful basis for my new build surface. The magnets are really strong. I don't think it's going to wobble or lose its position at all. Really nice design feature, definitely one I'll be retaining. So I've just given this a wipe down with IPA and it's looking beautiful. I've checked the surface with a ruler and it's quite flat in each direction. It's going to be a beautiful base to work with. On the underside we have the heated bed, and the thermistor circuit is inbuilt as well. So all that is very neat, and I'll be doing as much as I can to not have to change it, because this part of it I think is going to work. Now I have had a little bit of time to think, and I think I have a solution to my problem with the voltage difference, but it means straying a little bit from the original idea for this series. The answer is in this bag. In here is all the parts that I had acquired a couple of years ago to build my own Delta printer. I've got some really long ball screws. The idea was I was going to do it all from scratch. It was going to be custom and it was going to be highly accurate. We've got all of the wiring I need. I've got some spare lead screws. I've got a carbon fiber assembly for the actual Delta arms that hold the extruder. I've got stepper motors, but most importantly, I've got this. This is a RUMBA electronics board. It's more advanced than the ramps, but it retains some of the best features, and that is things like being able to plug in your own stepper motor drivers. Here I have the same DRV8825 steppers. That should enable me to keep that really high resolution that I want. Best thing about this board, when I looked it up, it is capable of taking anywhere from 12 to 35 volts, which means it should go straight into here without much dramas. If we look at the form factor, it's probably similar in thickness and quite similar in size to the original one. So it shouldn't be too big a job to make a mount to get this happening underneath this printer. I think it would be pretty stupid for me to not stick with this from here on in. There's only one problem. It's never been used, there's no firmware on it, so this gives us an excellent chance to download Marlin and show you how to configure firmware from scratch. Alrighty, here is our RUMBA board on the reprap.org page, and it's got all the information we need to know about it. And the first thing I looked up was the power supply. And we can see here that it takes from 12 volts all the way up to 35, so we can use the standard 24 volt power supply that came with the Zortrax, and that will simplify things a fair bit. It means we don't interchange fans and whatever else in our system. So the next step is to come to the Marlin GitHub page and download the latest release, and that is 1.1.8 at the making of this video. We're going to download the zip, we're going to place it into our Arduino folder on our computer, and then we're going to open up the main marlin.ini file. So here we are on the main Marlin screen, and pretty much all of our work is going to be done in the configuration.h and the configuration_advanced.h. So let's start from the top here and work our way down. I'm going to put myself in as the author here. Why not? Serial port we're going to leave as stock because we're going to do it over the USB. Baud rate we will remember for when we're trying to connect to the computer, and we'll leave that at 250,000. And then we get to our first bit where we actually need to change something, and that is defining our motherboard. You'll notice all through this file there are comments and notes to help us, and it tells us to go to boards.h to look up something that matches our setup. So we're going to come up to the top right and we're going to find that file, and it's exactly what we're going to do. Okay, now it's just a matter of finding our board. We can Control F, but we don't need to because already we've seen it. And we're going to copy and paste our keyword that is defined. We're going to come back to our configuration H, and instead of it being a board ramps 14 EFB, we're going to paste this over the top. And it appears I've missed the B, let's fix that. And we have now specified our board is a RUMBA. And what that's going to do is in the pins.h file, it's going to have all the pins listed for our board, and it's going to automatically configure Marlin to know that certain features are on certain pins, such as the stepper motors, hot end, thermistors, end stops, etc. Alright, let's continue our modification. So I'm only going to have one extruder. I want my normal filament diameter to be 1.75. We don't have a power switch. We're going to do that manually from the switch on the machine. So we leave this on 0. And now we come down to our thermal settings. Now our temp sensor, I'm actually unsure what it will be in the Zortrax. We can change this later. It's not really a big deal. So for now, we're just going to leave it on 1. What will happen is it will still read the temperature, but it might be slightly off in its calibration. So in terms of it working, it will be fine. In terms of it being accurate, it probably won't be until we update it. We have a whole bunch of safety settings, basically saying that if something's come unplugged and it's reading a temperature of 0, it's not going to turn on these heaters. And that's set to 5 for all of these things. So anything below 5 will not trigger. So if you've got your printer in a really cold room, this is the type of thing you might like to lower, but beware that you don't put it too low and then actually have the error it's trying to prevent. We've got our max temperatures for the hot end and the beds. Going to leave those as is. Now our PID, I'd rather auto-tune that later on, so I'm just going to leave it exactly how it is. Basically we find we're going to have a whole bunch of settings here that we don't really need to worry about because the defaults are fine. So we're going to keep scrolling until we get to something important, and here is our first really important thing, and that is thermal runaway protection. And we definitely want these to be uncommented. If you for any reason didn't want these on, you would add comments to the start and they become grayed and it will no longer be active. We definitely want to leave them on. Vital safety feature. Once again, we have some more default features that we can leave on. We're going to put our end stops on the minimum for all 3 axes, so therefore we'll leave it as is. Now this one here is something that I found in the past you might need to tune. Basically, if the end stop is triggering when it shouldn't, or vice versa, basically if it's in reverse, you change it from false to true for whatever axis you need to, and that will fix that straight away. Steps per unit I'm willing to leave as is at the moment, although I'm guessing the steps per unit for the Z is going to be a lot smaller because it's a ball screw, so I might in fact change that to 1000. This is the type of thing that I can verify later on by putting in specific G-code movements and measuring how much it actually moves to fine tune. I'm going to bump up my Z maximum feed rate just so I can home a little bit faster. Acceleration and jerk I'm happy to leave for now. That's the type of thing I will tune much later on. We don't have any type of Z-axis probe, so we're going to skip all of this. Later on, if I add a BL touch, this is where you enable it and therefore set up everything below that. Now this one here is an important one. Basically, we can reverse the stepper mode. So say we put in a command and we expect it to go to the right, but it instead goes left. We've got 2 options. We can either change it from false to true or vice versa in the firmware, or you can simply power down, switch around the plug 180 degrees, plug it back in. Both of those will do the exact same thing. Okay, another one that you might likely will need to change, and that is the direction it needs to home. So for us, we want it to go to 000, and that is the smallest value possible. You could home on the opposite side of the machine. So for instance, the X-axis could be homing at 200 instead of 0. And in that case, you would change this to a normal one instead of a negative one. But for us, we're going to leave them all as negatives. We're into the physical dimensions of our printer. This is where we put in the size. So the default is 200 by 200 by 200. We're going to leave it at that. The Zortrax bed actually measures 250, but I need to check the travel to make sure that's actually available to us. It's possible that when it moves past 200, that the fan or something like that becomes too close to the frame. So for now, I'm going to leave it at 200 and I can easily change it later on. So once again, a lot of this won't apply to us unless we add specific features. So we don't have a filament runout sensor, therefore we just leave this line commented and we ignore everything underneath. We don't have auto bed leveling, so we're going to leave all of this off. Okay, we're down to our homing section, and I quite often like to bump up the homing speed here. It's agonizingly slow. Since the Zortrax has a high quality ball screw, I don't envisage any issues with running that faster. Skew correction I'll leave off for now, but it might be something I'll explore in future. Okay, here is an important one. If I want to be able to change settings without reflashing the firmware completely, I need to uncomment this line, and that will enable me to use M500, 501 and 502 to retrieve, set and store values in the EEPROM. Right here is where we're going to set our preheat constant. So when you go to the menu and you go to preheat PLA or preheat ABS, these are the default values. So for me, I would like my PLA to be 210 and my bed to be 60. And for ABS, I think I'll keep it at 140 and I'll lower this one to 100. My LCD language I'm going to leave as English. And then we're coming to another important section. and that is to tell it we have an LCD screen. So we're going to uncomment this one, and we're also going to uncomment SD card support so we can print from the SD card. This one I've had to play with before. If you're having trouble reading from your SD card, you can try defining different speeds to try and problem solve that. Hopefully we don't need to worry. Speaker buzzer, this one is going to be very important for some people. If we uncomment this, we'll get the little blip beep that we're used to. If you hate that noise, then simply comment this and you won't have it. Alright, we've finally made it to the bottom of configuration.h. I'm going to do Control S to save. I'm going to come to configuration.h and see if there's anything here that I'm interested in as well. Okay, this homing one is probably worth looking at. You might have noticed on a lot of printers, it moves quite fast, hits the end stop, and then retracts a little bit and comes back slowly. This is where you set that distance, and this is where you hit the speed. So at the moment, it's been told on the X-axis, once it hits the end, to move back 5 millimeters, and then divide its speed by 2, so half speed until it triggers again. Same for the Y, and then for the Z, it lifts up 2, and then comes down at divided by 4 speed, which is of course quarter speed. Okay, here's a big one, linear advance. I'm going to leave it off for now, but this is a section where you would enable everything. You can also put in a default K value. I think once the printer is up and running, that's something I'll probably look at doing. But just so you know, it's as easy as uncommenting this if you have a new enough version of Marlin, and then following the steps in my calibration and setup guide. Okay, we have reached the bottom of this. There was very little we had to change on this one. At the top of configuration.h, define custom machine name, and then we can put it inside the inverted commas. And we're going to call this, of course, the Frankendoodle. That will now come up on the LCD screen for us. I'm going to save that. I'm going to come to Tools and set my port. The RUMBA does use a Mega 2560. So all we need to do now is hit Upload. Okay, we've hit a little snag, but problem solving is a great skill to have. So it's the internet, it's 3D printing, someone would have experienced this before. So all I did was switch to Google and type this in. It took me to an issue on the GitHub where someone said, not only do you need to enable the LCD and smart display, you need to tell it which one, which I'm quite sure I didn't do. And the advice here is to enable the RepRap discount smart controller, and that will set up the size of the screen and the type. So then I came back and I did a find for the word smart, and let's define it and see if that fixes the problem. All done. All right, let's have a look at the screen and see if it worked. Now, just before we get to that, we have on here sitting the standard spring plate Mark III bed. Now, there are a few magnets underneath here. There's not as many as in the Mark III, but the size is actually a perfect fit. And with a few more magnets, I think this would be a very viable option. Now, how amazing is this? The little cutouts on the back of the Mark III build plate to help it align actually correspond perfectly with some screw holes that held on the perforated plate, which means this is 100% match for fit. It's a little bit difficult to get it past the frame, but from this point onwards, that's on pretty good. I think I could use the remaining screw holes on the underside to attach some more magnets and hold this down firmly. So hopefully when Prusa are selling these in their shop, I'll be able to get one, and that is the bed sorted on this machine, and that is a fantastic result. So I finished plugging in everything that I can. That is everything that's plug and play. So it's time to very carefully power this on, staying well away from this end, and seeing if we can get the thing to move around, and with everything that's plugged in, potentially even home. All right, here goes. That wasn't meant to happen. All right, well, it's getting 24 volts, so that's not the problem. Let's turn it off. And I remember to get it to talk to the computer, there was a little jumpy here, and I had to set it to USB power. So let's put it back to what it was on originally, and hopefully it fires to life. Second time lucky. That's more like it. Okay, our firmware has fired up. Let's go to prepare and move axis. I hear movement. Y is working as well. And also Z. So if I plug in the bed thermistor, I get a thermistor reading of 17 degrees, which sounds about right. Although on my screen here I've just noticed that there's no place for the bed to come up, so perhaps I should have enabled something in the firmware. I'll have to go and check that. Well, it pays to read because I found this problem straight away. If we come to our temp sensor bed, it's set to 0 and written above in plain sight, 0 not used. When I switch around the plugs, temp sensor for the extruder was set to number 1 and the readings seem to be about right. So as a starting point, I'm just going to set this to number 1 as well, save and then re-upload to the board. Next thing is to put on the end stop connectors and see if we can successfully home the machine. Well, some time has passed and it's safe to say I've been tinkering for a while, but I've got it to the point where I'm happy to close the video because I've achieved my goal. Now I did have some problem solving to do. Firstly with the end stops, I worked out that the logic for the wiring was inverted, so I changed that in the firmware. And while I was working that out, I connected it to the computer and over the USB would send the M119 command which tells the end stop status. So I can trigger it with my fingers on and off and make sure that it was reporting as I expected. Also have some issues with getting the stepper motors to go smoothly. They are working in the meantime, but they will need some tuning for later on. And to troubleshoot that, I use known good stepper motors, and I also tried changing to the more common Pololu stepper motor driver. They do seem a little bit happier on these, but it does work on the ones that were in the board as I installed it. But none of that really matters because I'm probably going to change the stepper motors over to these 0.9 degree ones, which offer more resolution. Anyway, enough talk, time to show off the progress, which is not much, but it's a good first step. Let's power it on. And over on my control panel, I'm going to home the machine. So there we have it, it's the first part of our brain transplant. Now there is a fair bit of work to go, but we've at least reached the hello world stage. We've made some good discoveries with the bed, and I think I'm going to be able to add more magnets around the outside and use some sort of aftermarket flex plate, and that was really not expected. That's a huge bonus. In the next installment, I'm going to turn my attention to wiring, the main job being using a multimeter to trace the pin out for this ribbon cable down to the other end, planning to make a custom plug, as well as making proper plugs with DuPont connectors that will plug into what I have underneath there now, because at the moment things don't quite reach and it's a little bit messy. So until then, thank you very much for watching, and I'll see you next time. Happy 3D printing.
G'day, it's Michael again. If you liked the video, then please click like. If you want to see more content like this in future, click subscribe and make sure you click on the bell to receive every notification. If you really want to support the channel and see exclusive content, become a patron. Visit my Patreon page. See you next time.